So if you're watching this live, I would encourage you, you can call this number right down here, right? Call that number if you have any questions, okay? And I'm sitting by, I got my phone ready to ring. It's going to ring here if you call it. And you can ask me any question you want, and I'll help you, okay? Otherwise, right now, I'm going to go ahead and start working through as though you were sitting in the room with me, okay? All right, well, so let's pull that up. All right there. Okay, so now I'm looking at this. This is where we are. We're working through Geometry B, where we're looking at loading stuff into Lift. Your project is to try and earn these credits by demonstrating evidence. You know, we did a BLITZ the other day, which was using the definition of a parabola to derive the equation if we were given the focus and directrix. And now we're on to this one right here, okay, which is I can explain the relationship between central and inscribed angles and use it to solve problems. I've got in here, let's see, no resources added at this point, but I think I'm going to add in a link. So let me just add in a link here real quick. Sorry, I need to make a new one, don't I? Need to create a new resource here real quick. So I found this worksheet here, and you can use this same one. So this is a worksheet with info, okay? And there's the link for it, and I'll hit save. Maybe I should. There it is. It's in there, okay? So if you go to this step in your geometry claims, you should be able to pull this worksheet up. I'm going to work through some of these problems in this worksheet, use it a little bit. I'm not going to work through all of them, so I saved some for you guys to kind of work through as well. But basically, let's go back to the step information, and you'll have to add in some evidence here. Let's see, I have a spot for you to add some evidence, okay? Looks like, yeah, I've got the spots already in there ready for you to add your evidence. All right, so if we look back here again, we're talking about the relationship between central and inscribed angles. So to be able to do that, first of all, you have to know what a central and an inscribed angle is. It has to do with circles, okay? And so I'm going to just draw a circle here. Well, here's a circle, and oops, I always do that. Let me undo that. I just want to hide B. Okay, so we got a circle A. I'm going to place a couple of points here on A, right? So these points I can move around. Let's see, I'm going to try to draw a couple of segments between here and there and here and there. So I've got a couple of segments. Looks kind of like a slice of a pie or something here. And what happens is I can move this, right? It'll just spin around and around, whatever, okay? Move any of these guys, okay? So basically, the question is, how big could this slice get? You know, how big around could it get? Well, there's a lot of ways you could think about that, okay? One way to think about it is in terms of this angle here, right? How big of an angle would this be? And, you know, if you had it really closed down right here, it'd probably be really small, 0.1% or degree rather, 0.1 degree. And if I kept making it bigger, at some point it'd be 90 degrees. At some point it'd get bigger, we get to 180 degrees. And bigger, it would be 270 degrees. And then if I kept taking away all that pie, that pizza, whatever that thing was, sooner or later it'd be 359.99 degrees because all the way around would be 360, right? So let's just see that. I'm going to measure this angle now. Let's just see. I think I can do it this way. And that'll work. So hopefully you can see, maybe I need to zoom in, that says 48.3 degrees, right? So as I move this around, you can see that this angle right here, that is the angle where the vertex is at the center and the sides intersect the circle here, right? That angle can change depending on the size of the slice, right? And it goes up to 360 degrees. Now that should make sense, right? So then the question is, what do we call this angle here? So that is called, let me get a text button here. So the central angle, this is a central angle, which goes from basically 0 degrees to 360 degrees, right? That makes sense. The vertex is at the center of a circle, right? So that's why we call it the central angle, right? So vertex is at the center of a circle, okay? Let me put that down there. You just got to remember that term. Now, it turns out we would also measure, that's the angle. Another way to describe, how do we measure this part here is to think about, if this was a pizza, let's say, how much crust is this, right? How much is that? Well, it turns out this is called an arc, right? Let me just get the text tool back over here. So this is an arc, spelled like that, and it is part of a circle, right? In other words, it is, I'm just going to put in here, think of the crust, right, of a pizza pie, something like that. Just think about that like that, right? So this is another important term, okay? The arc is part of this. The central angle is part of that. So think about how big, just think for a minute, how big could that arc get? The arc can get all the way around, basically right up to, I'm going to get really close in there, 359.99 degrees, just all the way up to 360 degrees, right? So that leads us to something really important, that the arc, in terms of degrees, is going to be exactly the same measure as the central angle, right? So this is a really important concept. Let's see if we can add that in there, right? And the arc is exactly, or has exactly the same degree measure as the central angle. Or you could say a central angle measures the same as the arc it formed by the sides of the angle, right? So essentially what I'm saying is, this arc over here, right? That's just something to think about, right? There's nothing really profound here I'm saying. It should be kind of obvious, right? The circle goes all the way around, so how many degrees? We say it's 360 degrees in a circle. Well then, if I'm talking about those degrees by this central angle, you can see that it would go around up to 360. And if I'm talking about those degrees by this arc, you can see that still goes around to 360, and it's going to be the same. Okay, so that's the important thing about central angles and their arcs. And I think it's really, really, that's where we start, the understanding for this skill here, right? The next thing is to think about what's called an inscribed angle. So I'm going to place another point on here. I'm going to show you what an inscribed angle looks like. Okay. So an inscribed angle is an angle where the vertex is not at the center, but the vertex is on the circle, right? So let's get that written down here. So inscribed angles, the vertex, right, is not at the center, but on the circle. Okay, so think about that. So what does that mean exactly, right? Well, what it means is that this inscribed, it kind of comes, for those of you who speak Spanish, right? Escribir, right, means to write, right? Escribir. And for those of you that don't, but maybe you've heard of a scribe before, right? A scribe is somebody whose job it is to do the writing, like in a group or in a team, or, and Back in an olden days, maybe a king had a scribe who did all the writing for you, and the word script also, right? The word script also means writing. So this right here, inscribed, what it really, that word means is written on or upon, right? So basically, when we have an inscribed angle, the vertex is actually written on or upon the circle. That's where that kind of root comes from. So the vertex here, point E, is on the circle. Now I've created this so that as I move it around, you can see that I can move that circle around any way I want, right? And anywhere I put point E, it's still an inscribed angle because point E is the vertex and it is on the circle, right? So now the question becomes, how big is angle CED? How big is this inscribed angle? Okay, how big would it be? Well, I want you to take a look here. The central angle is 67. I'm going to make it maybe try to get it a little bit bigger. In fact, I'm going to zoom in real quick here so I can try to get something that's like an even number here. Let's see if I can. Well, I don't know. Let's just try to do something 90. Let's do a 90-degree angle. Get that pretty. It's about as close as I'm going to get to 90, unless I really, really, really. Well, maybe I can. All right, that's pretty close to 90. Right, there's very close to 90. So if that angle, the central angle, is approximately 90 degrees, then how big would angle E be? Well, let's measure it, okay? So we're going to measure that angle. So watch, because I'm putting C, E, D. Check it out. This is 90, this is 45, roughly 90. This is roughly 45. There's a little rounding going in there. 45 is half of 90. Half. So that's kind of interesting. Is that always the case? Well, check this out. What if I move this point over here? Yeah, it doesn't matter, right? The central angle is always half of the inscribed angle is always half of the measure of this intercepted arc, or half of the measure of the central angle, right? So that means, I guess, a couple different things, right? Like if this gets bigger, look at that, 146, now this is 73, right? It's half. 168 and 84.35, that would be double that. I get 168.7. It's really close. I mean, there is some rounding in there a little bit that this tool uses, but essentially it's always the same. So let's think about how big could an inscribed angle actually get. Well, if I go this way, look at this. Now, this is not half of the central angle, but that's because it's looking at this arc here, right? So now, how big could it get? At most, right about 180 degrees, right? Right about 180 degrees. And now, you see it gets up to, what the heck, if I keep going, it's getting bigger than 180. Let me get that back smaller again. Let's try that one more time. Let's move E. E is half of the intercepted arc. So what we do is we try to find the size of the arc, right? When the arc becomes a major arc, so this is now a major arc, meaning it is greater than half the circle, right? This arc, when it's greater than half the circle, we call it a major arc. So it's still 106 or 206.55, and that's its central angle, 206.55. So then this arc, or this angle here, is still half, 103.28, which is approximately half. So remember, we said a central angle could get as big as almost just right about 360, right? But check this out. If I get this really close to 360, well, I think I might have gone the wrong way. Let's get that. get that close to 360 anyway. This is going to, as this gets closer to 360, it becomes closer to 180. Okay, these are just examples here. All right, so I'll move that out of the way, move this out of the, move this out of the way. But the relationship is always half, and that's kind of the point. So let's write that down. Okay, so the inscribed angle, so let's get a little text in here, right? The inscribed angle always measures half the degrees of the intercepted arc or the central angle, right? The intercepted arc and the central angle, okay, that's what we were talking about at first. This part right here, there's the arc that's got intercepted, and this is half of it, right? Okay, so oops, I don't want to put in another thing there. So that's the concept, right? So now this is what we have to understand. That's the relationship. 126, this is half of 126, right? So that's the relationship. So looking back at our thing here, it says I can explain the relationship. So you need to be able to explain the relationship between central and inscribed angles. Central angles measure the same as the intercepted arc. The intercepted arc being the part of the circle, right? That that is formed by where the angle sides meet, right? So the central is the same and the inscribed angle is half. So the relationship between them is that inscribed angles are half of the central angle. And that's really important. Inscribed angles are half of the central angle. So let's take a look at some problems in here. It says you also have to be able to show you can solve some problems. I've clicked this, I put this link in there, right? And I'm just going to do a few. Maybe I'll just kind of scroll down here and talk through a few of these things, okay? So let me start with this guy right here, this first one. So it's saying find the measure of arc AB. So arc AB would be this minor arc, right? A minor arc because it's less than half the circle. Well, I see the central angle for it is 110 degrees, so it's going to be the same, 110 degrees. What would be the arc of ACB? That's the major arc. They throw that C in there to show you have to go through and around C. So that would be 360 less 110, right? Not including this part here. There's 360 in the whole circle, so 360 minus 110, that'd be 250. So this is 110 degrees, this is 250 degrees. Okay, here we have ACB, right? So that is the major arc. And we can see the measure of the minor arc is 170. So if this is 170, then arc ACB is 360 minus 170. So this would be 190. 190, right, plus 170. They have to add up to 360, right? These two arcs that are formed. Now they want to know what's the measure of angle AOB. So I'm assuming they mean this angle here. And it's going to be the same as its intercepted arc, 170 degrees. Okay? Scoot it down a little bit. We'll get into some problems that are a little more challenging here. They're not too hard, though, as long as I understand the relationship. So let's look at number 7. So number 7 says, find the measure of arc ED. Arc ED. Okay, so what do I know? Let's look at this. This arc right here, or this angle is 90, right? And what about AC? AC is a segment that goes through the center of the circle. We call that a diameter, right? A segment that begins and ends on the circle, right? And goes through the center is called the diameter, right? And the diameter cuts the circle into two equal parts, or what we call a semicircle. So the measure of this angle here, the central angle of arc AOC, the measure altogether, this is 180 degrees, right? 180 degrees. On either side, this side here is 180, and that side there is 180, right? So, because it's dividing it in half. 90 of it is here, in this part, right? So this part over here has to also be 90. And then this arc right here is 15, so that tells me this central angle is 15. So this remaining part where arc ED is the 90 less or take away this 15, right? Which would be, what, 75? So this would be 75 degrees. Arc ED would be 75 degrees. And this angle EOD would be 75 degrees. This is 15, and these are vertical angles right here. So if this is 15, that's 15 as well, right? All right, it says find the measure of angle COB. That's this one, COB. So this one's 15, we said, right? This one right here, also 15, but this whole thing together is 180. So this semicircle that's formed by the diameter is 180. So COB would be 180 minus this 15 degree part over here. We're taking away AOB. To get COB, we're just taking this whole semicircle, right here, and take away this part, right, to get COB. Just less that little slice. So 180, take away the 15 degrees, and we end up with 165. All right. Okay. 165. All right, we're looking at arc AB. Arc AB, which is this arc part right here. Okay. Arc AB would be, well, its measure would be the same as its central angle. Its central angle is vertical to this central angle, so these two measures are the same. And of course, this arc has the same measure as the central angle. So if this is 15 degrees, then this angle is 15, right? Because central angles have the same measure as their intercepted arc. And if this is 15, then I go through over here to the vertical angle. This has to be 15. This is 15, then this arc is also 15. Okay, and last says find the measure of angle BOE. So BOE would be 15 plus 90, and that's 105. All right, now we're getting into some intercepted arcs, right? Inscribed angles, right? So notice the inscribed angle is not in the center. So these are the problems that you're really going to want to maybe do a few of these over here for your evidence. So here I go, BAC. Well, BAC is an inscribed angle because the vertex is written on the circle. And what I know about the inscribed angle is that its measure is half the measure of the intercepted arc. So if this measures 90, we just did an example of that, then this would be half of that, which would be 45. If this right here measures 50, then angle A would be half of that, which is 25, right? If this is the inscribed angle is 85, then the arc is twice as big, right? If I'm going the other direction, right? If the angle is 85, then the arc is twice as big. So 2 times 85, which is 170. All right. Now let's see if I got something else I can do here. Oh, here we start getting a little bit more complicated, right? So the measure of angle C. So angle C. Well, I know this is part of a triangle, right? It's part of a triangle, right? Anyway, let's look at this diameter. This is just AOC. This chord or diameter AC would, it goes through the center, so it's a diameter. So remember, it's dividing it into 2 parts, right? It's dividing it into 2 parts. And each part, this would measure 180, because this is semicircle, and the other side would be 180 as well, right? So this is 180 degrees. Well, let's think about it. This is 25. This inscribed angle A is 25. Then this arc right here would be twice as big, which would be 50. So this is a 50-degree arc. 50-degree arc from arc BC, right? So then what would that mean this has to be? Well, the whole thing was 180. This is 50. So this part is 180 less the 50, or 180 minus the 50. So this is 130. All right, now we're going to look over here at this angle, right? If this arc AB is 130 degrees and angle C is an inscribed angle, then it measures half of that arc. So if this is 130 degrees, then this would be half of this arc, right? So 130 and half of that would be 65, okay? So that's really all there is to it. I'm not going to go through the rest of these problems. That leaves you some you can kind of work with. You can use this worksheet if you want. Now, what kind of evidence would you need to create? So what you're going to do is you're going to need to prove that you can explain the relationship, right? And then you're going to need to use it to solve a problem or two, right? A couple of problems, right? So make sure, I'm going to put it in here, make sure you explain a problem that includes in central and inscribed angles as well as their arcs. Right? So if you did one of these simplest problems right up here, this only involves central angles, right? This is only a central angle problem. So you would have to do more than this as evidence, right? If you did a problem that involved central and this one still only has central angles. But if you do one that has central and inscribed angles, like this one or this one or this one or this one, if you do any of these kinds of problems, they have a central and an inscribed angle. You could just do one as long as you explain yourself, okay? And what you're going to do is you're going to be putting it into flip grid. So let me go to the flip grid. Flip grid. There it is. Oops. Okay, good boy. And I'll tell you what, this is the Algebra 1 one. I don't want that. Well, let me see if I can get this real quick. I might be able to do this for you real quick. Let me go to my educator, log in here. And sign in with that and get myself logged in as an educator. Let me go to my Geometry B. Okay, so this is the Geometry B, and what I want to do is go to this one, and I'm going to add a topic, right? So here's my topic, and the topic is, let me copy and paste this, right, from right, I will call this central and inscribed angles, right? And then down here, I'm going to take this right out of lift. I can explain and solve. Oops. Okay, and close that other flip grid out. Okay, and then here was the instructions that we gave here. Make sure you explain, right, a problem. So, and you're going to need a couple of minutes, right? So I'll give you up to 5 minutes. You probably won't even need that long, okay? So let me go ahead and create that topic for you. And I'm going to copy this link. In fact, I'm going to share it out to Google Classroom. And I'm going to put it into our BLITZ right now. And hit make an announcement. And hit go. And here is the flip grid link that you will need to post your evidence, or to create your evidence, to create your evidence that will go in your lift portfolio. Okay? So unfortunately right now, right, we can't have you like we were doing with the BLITZ. You just sit down and have a at that time you could just sit down and have a little quiz and prove yourself. And I can't have you do that now. So instead you're going to need to go to this link that I just posted, and you're going to go in here and hit the response, right? So there will be a big green plus where here it looks like this, record a response. So you're gonna probably, what I would do is pull this up and record yourself, right? And record yourself explaining one of these kinds of problems over here, right? Where you explain it. And I would, even before you do that, I would just explain the relationship first, because you have to explain the relationship. So just remember, the relationship is simple. Inscribed angles are half the measure of the central angle, right? Inscribed angles are half. That means central angles are 2 times, right, the size of the inscribed angle. So you just explain that concept and then show that you can solve a problem with it, and you will be done. I'm going to hit save there. So that is all updated and ready to go. And nobody has called in, right? My phone has not rang at all. Give me just a second here. And I'm going to just double check that I have not been getting. I got a couple people watching. Had some people streaming and playing it back. But let me check this playbacks here. Yeah, looks like in the last little bit I've had some people jumping on. About 10 of you have been jumping on. But I'm going to go ahead now and I'm going to actually hit the save button on all this. Oh boy. Alright. Nobody has called me, so I'm going to be done here in a second. Let me do this. See, one other thing I want to check here. See if anybody's texted me either. I've got no new texts on that number, no new phone calls on that number. Checking to see. Yep, there's nothing new there. So, I've been waiting to see if you guys would call in. You haven't been calling in. I'm assuming that you either aren't watching, but I know that several of you are. Okay. Several of you are watching, so I'm assuming that you don't have any questions that you need to ask, right? If you do, get with me, give me a call, let me know, and I'll be happy to help you out. I'm going to go ahead and stop this recording now. I've been recording this whole thing, so I'm going to stop the recording and I'm going to upload it to YouTube.